So how a point is described in space? This is what the point is, point P, right? To describe this, we took three length dimensions in the rectangular system, but you can involve angle also. So by involving angle, you get two special systems. They are cylindrical coordinate system and spherical coordinate systems. In cylindrical coordinate systems, r, theta, z. Only one function is theta, angle. Other two are length dimensions, right? So u is r, v is theta, w is z. And what are these r, theta and w? Let us see. See, this is the point in the system. Here let us consider the frames of reference x, y and z, right? And if this is point P, let us assume the projection of this P on xy plane. If the point P is projected on this plane, xy plane, you can even assume this circular plane over here. If you see the projection on this xy plane, this point Q is the projection of P, right? Join this projected point, this Q from origin. This is origin O. This OQ is R. In cylindrical coordinate system, we use R, theta and Z. R is the distance of this point Q from the origin, where point Q is the projection of the real point P on XY. And what is theta? See this OQ, it is swept from this x-axis through an angle theta, right? Whatever angle this OQ makes with x-axis, how much angle it is swept away from this x-axis, that angle is theta, right? Q is the projection of P on xy plane and R is equal to OQ, and theta is the angle made by OQ with reference to x-axis. And what is Z? Z, it has its own general meaning. Whatever it has in the rectangular coordinate system, it is the distance in the y-axis, right? From this origin, this original base plane, how much distance it is away from the base plane. This point from this base plane, it is Z units away. That Z is given here, right? So now you know u is equal to r, v is equal to theta, w is equal to z. And next, when it comes to the unit vectors, you know the first parameter is r. So the unit vector corresponding to this will be in the direction of r. See this r, it is pointing this way, right? So from the point you have to indicate the radial direction along the, it is moving along the direction this way, right? So at the point you can mark E1 pointing the direction of R. And similarly E3 is very simple, it is also distance, so you can draw, it is Z axis. Z is in this direction, it is moving. So at the point P you can mark E3 along the direction parallel to Z, it's in the Z direction. And when you come to the angle, it is tricky because it is a cylindrical coordinate system which has the curve. This point here, this is a curve, right? So this point you have to, at the point P, you have to mark the tangential direction. If you draw a tangent at the point P, then that is the direction of E2, right? So this is how you mark E1, E2, E3, and the point P, it is written in terms of r, theta and z. Here the coordinate points are r, theta and z. Even E2, E3 directions are marked like this. Now let us see the transformation equations, or you can see the relation between x, y, z, r, theta, z. X equal to r cos theta. See, this is what x is and this is what y is and this is z. Right? So Z, there is no change, it is always Z, no change. So Z equal to Z, same value. But if you look at x, this is x and this distance is r. This is r vector, OQ vector, this is r vector. You can resolve this r vector into two components along x direction and along y direction. Along x direction, if you resolve this r, you are going to get r cos theta. Along y direction, it is going to be r sin theta, right? So x equal to r cos theta, y is equal to r sin theta, and z remains the same. So these are called the transformation equations. You see, on the right hand side, what you have is r, theta, z components. On the left hand side, what you have, your rectangular Cartesian coordinate systems. So from cylindrical coordinate systems, these are the parameters corresponding to cylindrical coordinate systems, r, theta, z. From these parameters, you can arrive at the Cartesian system x, y, z. So these equations are helpful to transform from one system to another system. If you know cylindrical coordinate system parameters, you can find rectangular coordinate systems. If you know rectangular coordinate system parameters, you can find the cylindrical coordinate systems. So this kind of transformation is helpful with the help of this kind of transformation is possible with the help of these equations. So they are called the transformation equations. X equal to r cos theta, y equal to r sin theta, z equal to x, z equal to z. Now, from these two expressions, you can find r also. That means the reverse. If you know Cartesian system, how will you find cylindrical coordinate system parameters? For that, we will see this. By combining these two, you have cos theta here, you have sin theta here. So you square and add these two. You get r square cos square theta plus r square sin square theta, which is equal to r square. That means in the left hand side, you get x square plus y square. You take a square root, you get r, which is equal to square root of x square plus y square. So by combining these two, you get this relation, and you have sin theta and cos theta here, you divide it. Sin theta by cos theta gives you tan, r gets cancelled, right? On the left hand side, you get y by x. So when you find theta, you get tan inverse of y by x, and z remains the same. So these are the transformation equations helpful to transform from from Cartesian systems to cylindrical system. The first one, cylindrical system to Cartesian system. If you know r theta, you can find x, y, z. Second one, if you know x, y, z, you can find r theta, z. You can transform one system to another one. Now what we are going to do is, we are going to find H1, H2, H3. Maybe in your lower classes you studied this and you know the parameters, metric parameters. What are the metric parameters for cylindrical system? But now we are going to derive it. And you know the method how to derive it because I showed it in the rectangular system. ds square is dx square plus dy square plus dz square. We are going to find this ds square. And you know the general expression for ds square in terms of h1, h2, h3. Finally, we are going to equate these two, right? Thereby, we are going to find h1, h2, h3. For that, first what we are going to do is, I have named it as equation 1. Next, this x I am taking. X is function of r theta, right? So any function you can write in terms of partial differentiation like this. Dou x by dou r into dr plus dou x by dou theta d theta plus dou x by dou z dz, right? But here we know it is not z parameter is not involved, so this term here itself you can make it 0. You can use only these two, or in most of the books it is included, so I have included the third term also. Z term also I have written. So dx is written like this. So this is what we are going to find. We know x is equal to r cos theta. So dx you can find, that is equal to dou x by dou r. Find dou x by dou r dr. Dou x by dou r, it is only cos theta because only r you are going to differentiate. It is a partial differentiation. So only cos theta and remaining dr written. And next one, dou x by dou theta, right? So the same x you are going to differentiate with respect to theta. So it is r minus sine theta. So minus r sine theta d theta. And next there is no z component. So dou x by dou z is 0. So that part is 0. We get only two terms. Are you all getting this?
Yes, ma'am.
Yes.
Okay, okay. I told you the strategy. ds square is this. We know what is x. So we are going to find dx square from this. We find dx first, then we are going to square it. Then we are going to find dy. The same way we will write and find dy and we will square it. We will find dz square, then all sum up you will get one expression. That you have to compare with the standard expression in terms of metric parameters. That's what we are going to do. So now it's your work to find dx square. Do find it and tell me what is dx square. It is going to be dx the whole square. This term's whole square, a minus b the whole square. You apply and tell me the result.
Ma'am, cos square dr square
Just a
plus
minute. Oh, why it is going? It is hiding. Okay, tell me, pa. Tell me, pa.
ma'am, cos square dr square plus r square sin square d theta square minus 2 times cos theta r sin theta dr d theta.
Yes, very good. I think I made a mistake here. This square is missing here. Control L. Yes. This part I have missed the square part. Please correct it. This is a square. Everyone got this?
Yes, ma'am.
Yes, ma'am.
Yes, good, very good. Let me move on to y part. Then y also now can be written in this format. dy I will write like dou x by dou r dr plus dou y by dou r dr plus dou y by dou theta d theta plus dou y by dou z dz. Then for this I will find the original dou y by dou r I will arrive at. Then I will take square. Y is r sin theta. Oh my god, the time is over. This alone we will complete. dy is this. Are you getting this?
Yes, ma'am.
Dou. Okay. Then
Yes,
if you
ma'am.
take the square, are you getting this?
Yes,
Yes,
ma'am.
ma'am.
Very good. You are fast. And then you know this is equation 3 and z is equal to z. So dz is dz. So dz square is dz square. So it is very simple for us. Now substitute all these equations in one. That is ds square. ds square is equal to dx square plus dy square plus dz square. You substitute and you check whether anything is getting cancelled and tell me the simplest expression for ds square. You know ds square is dx square plus dy square plus dz square. Substitute and tell me.
Ma'am, it's dr square
Mm.
plus r square d theta square
Mm.
plus dz square.
Very good. Very good. This is what we get as the simplified version. Has everyone done this?
Yes, ma'am.
Okay. So next what we have to do, we have to compare it with the general expression in terms of metric. So this is what the general expression in terms of metric parameters, right? Here u, v, w, r, theta, z. So dr square, d theta square, dz square you get. So you compare this, h1 square becomes 1, h2 square becomes r square, h3 square becomes 1. So this is what you get. h1 square is 1, h2 square is r square, h3 square is 1. So h1 is 1, h2 is r, h3 is 1. So the metric parameters for cylindrical coordinate system is 1, r, 1. Have you got it?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Another homework you can take down. you know the general expressions for gradient, divergence and curl. Substituting the specific parameters for cylindrical coordinates, you find gradient, dive and curl for cylindrical coordinate system. You know gradient in general system, you find it for cylindrical system because you know H1, H2, H3 what they are, even E2, E3 what they are, U, V, W, R, theta, Z. So you find exact expression for cylindrical system, for divergence, for curl. You do it and we will see in the next class.